spirit animal was a golden retriever, so I was like, cool, I'm just gonna look at dog videos for 30 minutes. Love it. What life has, tough life.
Oh, sorry. You're good.
Dog videos right now.
Oh, they're adorable. I don't blame you. So we should talk about Git. We're going to have to use it for this class, particularly for submitting work. I just want to take a quick poll. Who logged into GitHub Classroom and was able to at least look at the assignment? Maybe they didn't clone it or push anything yet, but they logged into GitHub Classroom and they were able to get in okay. Who did that? I know some people did it.
Are you talking about for Zorkington?
Yeah, for Zorkington. Who logged into the GitHub group for Zorkington? Okay, who has not logged in? A few people. Okay, cool. Tonight, I would love it if we could walk through logging in together. All right, I sent myself an invite. I've saved it so I can actually log in, like all of you will log in, and then we can see what it looks like to go through it. And this is a way that you'll be able to get your work back to us. This applies to Zorkington project. This will apply to the Tic-Tac-Toe project. If you have more projects throughout the course, which we will, that you need to submit, you can use this for those too. The idea with GitHub Classroom is that we're going to be able to more easily see the work that you push up versus having everybody have different names for their projects that are all slightly different variations on the word Zorkington or Tic-Tac-Toe or something like that. And then we just have to send around the links to those repositories using Slack or something. This is a more organized approach. It's sort of like having an inbox for the teacher. Anytime that you push your work using Git, we get to know, and then we're able to go and see. And I'll show everybody how that works, because I understand that people don't quite understand Git yet, and it's kind of confusing, and I get that. I've been there. I know what it's like to have to deal with Git. It is kind of a bear, but we're going to get through it. So let's talk about Git as a version control system. Okay, so what the heck does that mean? What it means is that when you make changes to your files and you tell Git about those changes, Git saves the changes, but also the way the file was before the changes. It saves both. Okay, it doesn't duplicate the files. It's not wasteful in that way, but to you as a user, it feels like there's just a whole endless stream of copies. Every time you make a change and you tell Git, hey, I've made some changes, and you make a message about it, which is called a commit, Git will take a snapshot of the way that your folders and your files look just in that one project, not across your entire computer, just in that one project. And then you can look at how you've made changes throughout the project. And you can even backtrack. You can go back in time to an earlier version of your project and then jump forward back to the most recent version if you want. And then the really cool thing about it is that you can do what's called branching. So you can have one path that's like A, B, C, D, and then you can have another path that's like A, B, C, and then a branch, and then E, F, and G, which are all these changes that you can make to your code base, and that they can be divergent. They don't have to rely on each other. And it's a nice way to be able to experiment with changes to your code and not concern yourself with whether or not that experiment is a success or a failure, because you can go back to the way it was beforehand, which is super fun. And I'll show you what that looks like. So let's talk a little bit about some words about Git. People will often kind of call it a distributed version control tool. So what does distributed mean? It means that if I have a folder with Git files in it and my code in it, and Missy has a folder with Git files in it and her code in it, and Ron has a folder with his Git files in it and his code in it, we can all work independently on the same code and see each other's changes if we want to. And we don't have to rely on there being some sort of like central database that manages who can see what at what times. So the big advantage of Git is that everybody can work on their own code without there being something in the middle that kind of prevents them from being able to have full access to everything. It didn't used to work that way. There was there were a number of pretty well-known tools that existed in the 90s and the early 2000s and even into the 2010s. Probably the most popular one was called Subversion. A lot of people use that. There's another one called CVS that existed before that, which stands for Current Version System. These were what are known as centralized systems, and what that meant is that if you're working at a company and you wanted to work on a feature, you would have to check out the files that you were going to have to change and edit that had to do with that feature. And until you were done with your feature, those files would be checked out, and if somebody else needed to check them out, then you would have to go and have them request you to release permission on that file and like put it back. Like there's only one version of the file, and everybody had to like coordinate who was working on what files at one time. And that was very challenging. And Git doesn't work that way at all. There's none of that. So you don't have any concern about like, oh, does Riley have the latest version of the file? Like, Riley, can you check in your work so that I can do my work? Come on, Riley. Like, what's the holdup here? You said it was only going to take 4 hours. It's been 4 days. What's going on? Like, these kinds of conversations used to happen all the time, and they were very stressful, and they made people less happy. And Git made people more happy and less stressful, which is a big reason why I think it actually succeeded. Almost everybody uses Git or something very much like Git now. So it won simply by the nature of it being a tool that developers wanted to use versus a tool that they didn't want to use. That's like the ultimate sign of success for a developer tool. Okay. However, I want to make a quick distinction here. Git is not GitHub. GitHub uses Git, all right, but it is not Git itself. It's not the owner of Git. It doesn't have any control over your files. GitHub is just another place where you have a repository that's managed by Git. All right, it's like a computer or a folder in the cloud that you're able to put your files on. We'll talk more about that in a little bit. So we spoke really quickly about this version control systems. It's a lot like a file system, all right, but it does some other things, some extra things that file systems don't do. One is that it's a log of changes to all the files that are in a particular place. So let's say I have my live folder and I put it inside of version control. All the changes I make to my live folder, if I add any files, if I delete any files, if I edit any files, if I rename any, all those changes will be tracked individually. And if I commit them individually, I'll be able to step through those changes one by one, which is really nice. There's sort of a trade-off there between number of changes made and ease of going through those changes, okay? But you can, if you're sort of clever about it, have there be nice fence posts in the history of your project that you can step back through and actually have known points in your code where you can go back to before you put a certain feature into your code base, for example. Or right before a bug happened, and you're like, why did this bug happen? Let me go to the commit just before this bug was introduced and find out what the code was like then, and compare it to the code after the bug was introduced, and find out like where could this bug exist? It must exist somewhere in this code that was written between before and after. And this is nice. In addition to the changes, it logs who made the change and when they made it, which is really great because you can now, it's like an audit log. If somebody goes in and writes some awesome feature, they get credit for that feature. If somebody goes in and makes some change that introduces a bug, well, you know who to talk to about the bug. And they're able to fix it faster because they were the ones who were most familiar with that code. So it's a really nice system to have. The messages, these are often overlooked, but very important. The messages in Git that you leave when you make a commit are the most important part because you get to say why you made the changes that you made. So you can actually leave like notes to yourself in the past, right? Has anybody here ever played Dark Souls? Okay, so one person, that joke fell flat. Okay, two. Well, there's this feature in this video game that you don't play with anybody else, but lots of other people play it. And like, let's say there's like, you know, some demon in the dungeon that like completely clobbers one of the players and kills them. When you die, you can leave a note for somebody else. Like, beware the demon around the corner.
Except that they leave a note on the edge of a cliff that says there's treasure at
Yeah.
the bottom of this cliff.
Yeah. That's the other kind of note that can happen a lot too. Okay, so but you can be the one leaving your notes here. So the advantage here is that you can tell yourself in the future what you did in the past and why. Oftentimes you'll forget why you wrote code a certain way or why you did something, and this is a way for you to remind yourself. So if you actually take the time and write a good message, like at least a sentence, sometimes two. If you need more than that, you can write a little paragraph below the headline. That can be super helpful. So version control is super important because for development teams, you are all going to be like working on the same code base together, and that means, okay, it's sort of like a game of operation where everybody has a pair of tweezers, all right? And sometimes two people are touching the body at the same time with the tweezers, and the buzzer goes off, and you need to be able to coordinate each other's efforts, okay? Even though you all have a copy of the full code base, you still have to get those changes together and actually get them onto a computer that runs your code. And very few developers work alone in isolation. It's a common myth that developers are isolated. There certainly are some that are isolated, but that's not the common path. Most of the time, people are working together with at least two or three other developers. So just be aware that like you're going to have to work with other people. It's part of the job. It's cool. We get to talk to each other, like have fun, and make cool things. It's a pretty cool gig, right? I used to work in hospitality. Not quite as much fun as hospitality is not as much fun as development. All right, so for different people, it serves different purposes, okay? So for individuals on your team, what you get out of it is that you can work effectively, and you can look back through the project and find why things are done a certain way. For product managers and for clients, it sort of serves as like an overview of what's changed in the product or in the project and how much work is getting done. Like I said, it serves kind of as an audit log. You can say, okay, well, my team made this much progress on this week, and so they're probably going to make about this much progress on the next week, right? It kind of serves as a reality check to the tendency to like overcommit, because you're like, well, you only were able to produce this much last month, so you're probably going to produce about the same next month, right? The speed that you run today is a very good indicator to the speed you're going to run tomorrow. And you might change that speed, you know, a little bit over time, but it's probably not going to change dramatically from day to day. So, all right, for system administrators, a lot of code, I should say, that gets deployed today is deployed as source code, not as a binary, and I'll try to draw a distinction in a little bit. But JavaScript, what we're writing in Node.js for a server and for browser code for the client, they both get put on computers to be served to end users' browsers as source code that you look at in your editor. It's not like compressed and turned into ones and zeros and then, you know, put on some computer as a file, like an executable that you see in Windows. Almost most of the code, I should say, that you deliver for web programming, which is what we're focusing on in this course, is delivered as source code, not as some kind of like executable binary, right? And the reason why I'm making that distinction is that for sysadministrators, they can take that code and using Git, they can overwrite the last version and be sure that they're not like missing any files, that they've gotten all the files from the project. And as another benefit of this, if something goes wrong with that code, if there's like a dramatic bug that's like causing a huge problem, they can revert back to a prior state of the program without having to like guess what changed. They can just go back one step and go back to the way it worked. For QA professionals, what these people are responsible for is making sure that the application continues to run the way that it's expected to run for the end users. And if they aren't sure why a bug was introduced, they could look at the code in the source code repository manager of Git, which is great. They can also add their own code to this without having to use something like spreadsheets in order to track bugs. So they can track those inside of the code base. It's a benefit to a lot of people. Okay. All right, so if you're going to install Git, which you all have done already, this is what you would do. If you're on Mac OS and you have this package manager called homebrew install, you would do a brew install Git. You all have Git installed already, so you don't have to follow these steps. But if you don't have homebrew, or if your computer, you don't want to install it for some reason, you can also go to git-scm.com/download/Mac, and you can get it on your computer. Also, Mac comes with an older version of Git installed by default anyway. So if you have a Macintosh that's in the last few years, the version of Git that's on there is probably suitable for your work. It might not be the most up-to-date version. It might be like a few versions old. But to be honest with you, Git is a pretty mature piece of software at this point. It's not changing a lot from version to version. And unless you're talking about a Mac computer that's like 9 or 10 years old, you're probably going to be fine. For Windows, you have to install the Windows Git version. I don't think it comes installed on Git on Windows by default. Like Git doesn't come on Windows by default. And for Linux, I think on some distributions for Linux, is there anybody in this room who's using Linux right now for their personal computers? No. Okay. So if you were, there's ways to install it for Linux. It was originally designed as a tool to develop the Linux source code. So for the kernel of Linux, it was designed by the creator of Linux, named Linus Torvalds. And anyway, this was the original intent. So it works great on Linux, I guarantee it. Linus would make sure that that was fixed if it wasn't. Okay, so this is what I mentioned before. Git and GitHub are different entities. Git is a tool. GitHub is the place that you can use that tool very often. So think about, Git as sort of like I'm trying to make an analogy here. Git is like the laser cutter, and GitHub is the makerspace that has lots of laser cutters. Okay, they're separate things, even though they're associated with each other. Okay, but people make this mistake all the time where they think that Git and GitHub are the same. They're not. They just share a common name. GitHub was created back in 2007, I believe, by two software developers who wound up making a lot of other tools, and GitHub is one of those tools that they ended up building. GitHub's great. It's a great piece of software that we all get to use and enjoy, and now it's owned by Microsoft, and it's probably going to be free forever, which is great. One thing that you should know is that you don't have to use GitHub in order to use Git collaboratively, okay? Particularly like the Linux developer team, they don't use GitHub. They will put their changes to GitHub so that they can be inspected by the community at large, but in terms of their day-to-day work, they actually email the differences to each other. They use a special program that makes those changes formatted as plain text and then those changes are sent to one another as emails. They're not actually shared through a tool like GitHub. So Git was never designed to be used with GitHub, so GitHub kind of actually augments Git and adds a nice fancy user interface on top of it, but you don't need it for it. It works just fine without it. All right. So most people are going to use it locally. All right. Even though it's a distributed version control system, we're going to use it locally for our lessons today. And then at the very end, we'll push some code up to GitHub right before this lesson concludes. Yeah, Ron.
I've used Subversion before
Yep.
in a company setting. So basically, you would use this client program called Tortoise, at least
Sure.
for Windows. But then the company had their own server.
Yep.
And then we pushed all the stuff there. So like with Git, can you have a Git server like within a
That's what most people use GitHub for.
right, like without using GitHub?
You can use it. Yeah, you can set up a Git server without GitHub.
Oh, okay.
Yep.
Cool.
Yeah. Remember that Git is designed to be used without GitHub, so it works great without it. Yep. It's a little bit like you have to set it up, but it works.
Okay.
Yep.
So the one on the like how you say Git master or whatever.
Yep.
So the master would be the one on the server.
It depends on how you set it up, but it could be.
Yeah. Okay.
Yep.
Okay.
Totally. All right. So you can run it on one computer just fine, but the thing about Git is that you want it for yourself and you want it for your coworkers, so that you can collaborate on stuff. Okay. So a repository, all right, contains the version history of a collection of files. It's not created for you automatically. It's not built by magic. Okay. So we'll sometimes call this thing a repo. If I use the word repo or repository, they're interchangeable. Okay. And what the repo is it comprises all those files and subdirectories inside of a single root directory. Again, this does not mean that your entire machine is under version control. You almost never want to do that. What you usually want to do is put one small project, under version control and have Git for that project. And then if you have another project, you'll put that under version control, but a different version control. You'll set up 2 repositories, one for each project. All right, so a mistake that I see a lot of people make when they first get into Git is they go, cool, I'll make a repository, I'll put it at code, I'll put all my code under one repository. That'll be simple, it'll be easy. It is not. You probably want to have a repository for every one of your sub-projects. So if you have a project for Zorkington, put a repository inside the Zorkington folder. If you have a repository for guess the number, a folder for guess the number, you'll put a repository into that folder. Okay? When you create one for tic-tac-toe, you'll put a repository into that folder. And Git works much better when it tracks a single project, things that all relate to each other, rather than having lots of different files and folders that are not related to one another, but you're just like making changes on them for different reasons. Okay? So that's my recommendation. I am very adamant about it. If you do put code under source control and everything underneath it under source control, I can help you fix that. It's not the end of the world. Again, it's very hard to break things with Git, just like it's very hard to break things with JavaScript. So we will be okay if you make a mistake, and we'll fix it. All right? Okay. Oh, you know what? I need to go over the rest of these. So I mentioned that they're not created by themselves. They're not made out of magic here. So you have to use this special command git init when you first create the repository, one time. You're only going to run this one time per repository. If you try to run it again, Git will actually yell at you and tell you that, hey, this folder already has a Git repository in it. I don't think you want to create another one. There are ways to force it to happen, but you definitely don't want to do that. So if it complains, read the error, right, like we just discussed, and then it'll actually have instructions in there on what to do next. Okay, the most common command that you're going to run when you're using Git is probably going to be git space status. So git status, This is the program. This is the argument to the program. So Git is the program. Status is the command that you're telling Git to run. And it's going to describe the state of the current repository for you. And it might look different depending on where you're at. When you first create the repository with Git init, it's going to give you a different set of information than after you've added some files. And it's going to give you a different bit of information than maybe after you've deleted a file or edited one, okay, or made a commit. So what you get out of Git status changes based on a whole host of different things that can change inside of your repository. So it's really important, if you're stuck, you're not sure what to do, you can always type Git status and you'll never break anything. Typing Git status will always give you information and never break anything. Okay. So we're going to create some repositories here. Okay. Let me see if I can make this a little bit wider and a little less tall.
Full screen?
I am kind of in full screen already. I don't know if I'm going to break things if I go like this. I might not. Okay, so here's what we're going to do. Open up your terminal if you haven't already. So open up your command line. And we're going to cd, so change directories, into our code directory from wherever you are. So if you're already in code, then you might not need to change into it. But if you're not, go ahead and cd into code. And here's what we're going to do. We're going to make a directory, mkdir. That's going to be called shopping. So make dir shopping. There's going to be a space between make dir and shopping. It's going to make that directory named shopping inside the directory named code. Then you need to change your directory into shopping. So cd shopping after you've created it. So you're then that's going to be changing your current directory into shopping. Once you're inside of shopping, we're going to git init. So git space init, I-N-I-T. And that's going to create all of the files that Git needs in order to start tracking anything that you change inside of this shopping directory. Okay? And then lastly, once you've done git init, type git space status and see what it tells you. I'll give you a minute to fill those in, and then I'm going to see where people are at. And I'm going to do the same thing right now. So here's what we're going to do. If you haven't done it already, I'm in code live, so that means I have to cd back to my home directory. I can see that I'm in users Mansfield. So I need to cd into code. So I'm in code now. And I do mkdir shopping. Present working directory is still code, even though I created shopping. So I'm going to cd into shopping now. And now I'm at code shopping. I can see that if I do pwd. And then the last bit that I need to do here, I need to do git init. And it'll say initialize empty git repository in users Mansfield code shopping. And then lastly, I need to type git status. Did anybody have any problems with any of that? Is anybody stuck on any of this? Just want to make sure. If you are, that's cool. If you're not, that's cool too. All right, so I'm going to go back in here. Does anybody need me to re-review any of this? Okay, sweet. You should see something like this when you're done. No commits yet. Nothing to commit. Right? And it's telling us, hey, if you want to be able to commit some stuff, create some or copy some files and use git add. So we just haven't gotten there yet. We're going to now. All right. So here's a core concept for us. There's some weird things about Git. Hey, Alex and Ron, sorry. There's some core concepts about Git that are a little alien, shall we say. Git's made by smart people who don't have a super great sense on user interface design. and they name some things in weird ways, and there's some weird conventions, so we just want to go over them so that we can catch you all up to speed. So Git is a two-step process, all right? First, you have to add changes to what is known as the staging area. So when I create a file, it's not automatically tracked by Git. It doesn't do that. That would make too much sense. So what Git does instead is it has you add the file to Git to be tracked. And from that point forward, Git will start tracking any changes you make to that file. But if you don't add it, it will not track it. It'll just ignore it and pretend it's not there. And then after you've made your changes, you can commit that file to Git. And what a commit does is it does that snapshotting thing that I talked about earlier. It makes a copy of those changes that you've made and then saves them. Okay? Cool. So after you make that commit, your staging area is now empty, because what happens is after you've added files to the staging area, a commit takes those files and moves them into the Git repository, the changes to the files I should say, moves them into the Git repository, and now the staging area is clear. So think of it like a warehouse that moves boxes to the loading dock, and then the truck comes up, backs into the loading dock, gets filled up, and then drives off. The loading dock is empty when the truck leaves. And then there's still boxes in the warehouse that might need to get added back to the loading dock. Okay? So this is sort of why it was designed to work this way. Sometimes you have files in your repository that you don't want Git to track. You only want to track certain files. We can teach you how to do both of these things, to track everything inside of there and to add stuff step by step. Okay? So here's what we're going to do. We're going to create a shopping list inside of the shopping directory. And this is the next step of this lab, so we all want to start following these steps. We want to create a file named groceries.txt, groceries.txt, all right? And after we've created that file, you can do that using Visual Studio Code. You can use the new file button in Visual Studio Code, and that's cool. You can then, if you want to, I should say, let me rephrase this. If you want to open up the shopping directory in Visual Studio Code to easily add that file, use that code dot command that we have been practicing. That'll open up the current directory inside of Visual Studio Code. Then you can create the shopping.txt. And inside of there, we want to add 3 lines. 1 line with the word milk, 1 line with the word eggs, and 1 line with the words chunky monkey ice cream. And now we're going to start adding these changes to Git. All right? So we're going to type git status to make sure that we know where we are. Then we're going to do git add dot space, I'm sorry, this is a comment, git space add space dot. I misunderstood what this was saying. And then we're going to do git status again and see what's been added to be committed. So this file will then be in what's known as the staging area. And then on the next slide, we will actually commit this file. So let's see these changes. So inside of here, I'm going to open up this directory with code. So code dot to open up the whole directory with Visual Studio Code. Here we go. There's nothing in it. So let's create I know I'm in this directory because at the top of the Visual Studio Code window, I have the word shopping. Let's create a file in here. Call it groceries.txt. Groceries.txt. Cool. And let me make this a little smaller. So now I'll add a couple of things in here. Milk, eggs, chunky monkey ice cream. Okay. And I'll save this, go back to my editor. Go back to my console from my editor, and then do git status. We have on branch master, no commits yet, but we have this untracked file. We see that groceries.txt is untracked. So now we're actually going to track it. So we'll do a git add here. We can do this two ways. We can git add dot to add everything in the directory, which would work fine. We can also do git add groceries to just add that one file, which will also work fine. For now, I'm going to follow the instructions. And if I do git status again, we see that we have a new file, groceries.txt, instead of an untracked file. So that means that groceries.txt is now being tracked, and groceries.txt has some changes in it that we can commit. Okay, so let's see what the next set of slides says to do. Let's follow that. All right, so we're reading the, wait, do we have a commit at the bottom? We don't, but let's commit it. So we're going to commit this change, okay? What we're saying here is that we have not actually committed the changes that groceries.txt has inside of it. If we go back to the terminal here, we note that Git tells us what we can do differently here to pull this out. It says that you can use git rm -- cached, and this angle bracket, file angle bracket, this means if you want to remove a file from the stage, you can use this command that's inside of quotes to take this file back out from where it's currently added to the stage. I'll demonstrate that before I move forward and add it back in. So if I did git rm -- cached, and then groceries, and if I did git status again, you notice that we're back to being untracked. Okay, we're back to being untracked. You can take it out of the stage after you've added it into the stage. A lot of times people skim over the status messages, but they're almost always helpful. Okay, and now before I add that back in, I'm actually going to create an empty commit to this. So if I can do git, it might not allow me to do an empty commit. Let me just check. Initial commit. Yeah, okay. It won't let me do that. I need to actually add the groceries to the stage before I can do a commit. So let me do that again. I'm going to do git add, and this time I'm just going to type in groceries. And if I did git status, I see that they've been added to the stage, and now I can go back and commit with initial commit. This is almost always the first commit inside of a repository, just a heads up. Usually you have a repository that has like one very small file in it, or maybe even an empty file, but a file nonetheless, and you'll start off your repository with this initial commit.
Does it have to be capitalized?
It does not. It's actually, I can type this in any way I want. So I could say, this is the initial commit. And I don't even have to have those words. This is just a convention. People just do this out of habit. There's nothing forcing you to do this, and you don't have to spell the words right or use those words. But if you do, you'll just be adhering to the convention that many other programmers follow. Okay? Anything that you put in the commit message is fine. It doesn't have to be spelled a certain way or in a certain order. The commit message is completely optional and arbitrary. I shouldn't say optional. You really should have a commit message, but it's arbitrary what you put in there. You can do anything.
So you can even leave it blank.
You can, but I would discourage you from doing that.
Yeah, you really don't want to make it blank.
Ira?
So
The message.
Alex, just a second. I just got to have another question really quick, and we'll get back to that.
Are you when you type commit -m, are you committing everything that's staged?
Yes,
Okay.
that's correct.
So could you type that in such a way that you're only going to commit some of the stuff?
I would have to take the file back out of the stage if I only wanted to commit some of it.
So if you're going to commit, you commit everything that's staged. You can't say like.
You can't. commit some of the things that are in the stage and some of the things that are you can't commit only some of the things that are in the stage. You have to commit all of the files that are in the stage. I will preface what I just by saying that there is a way in Git. We're not going to do this. Omit that, but that is so much more important. Okay. So let me go back to just typing initial commit here really quick. And I'll just commit this. Cool. So this is what we see when we see something that's a successful kind of commit. Now I'll do git status again. And we'll see that we're on branch master. There's nothing to commit. The working directory is clean. These are the kind of messages we get from git status when everything's going great. I will explain what on branch master means a little later. And working directory clean means that there's been no changes to our files since we last committed. Everything is exactly as it was during the last commit. All right? So that is what a good commit looks like. Now let's go back to the slides really quick. This is our commit that we just made. All right, I demonstrated this instead of showing this file. Is everybody at this point right now? Or does anybody need to do this before we go forward? Or is anybody stuck on anything? Nothing so far? All right, cool.
What's the -m for?
Oh, that is a shorthand to add a commit message on the command line without having to add it from my text editor. And there's a good reason for this. Git, by default, uses a very cryptic and old text editor called Vim in order to add its messages. So if you omit the -m, it will open Vim and expect you to be able to use it to write a commit message and then save that commit message and then close Vim. And those three things can be very challenging if you've never used Vim before. I know it sounds simple, but there have been many a programmer who have gotten locked up for an hour or two trying to figure out how to close and use Vim the first time. It's not like a normal text editor. It's not like Visual Studio Code. It comes from an era from before there were mice, and so everything was driven via the keyboard. And that's why it's sort of baroque and cryptic in the way that you use it. It is also very powerful, but you have to learn how to use it before you really get the power out of it. So by using the -m, you avoid all that nonsense. And if you accidentally forget the -m and you end up in Vim, I can show you how to get out of that. All right? And probably what I'll do is I'll make a short video about how to exit it, and I'll put some notes up on the board that people can recall in the future if they ever get stuck. Does that make sense? Cool. All right, great. Let's go to the next slide here really quick, because I want to show you how these messages can be helpful. Okay, so this is what's called a commit message, and I'll show you how to get this in just a moment. You run this command called git log. So git log is going to actually show you the messages that you have in the past and when those messages were created along with their changes and by whom, and this special thing called a commit SHA or SHA or a hatch. All right? So this long number here is unique to you and the machine that generated it and the changes in your files. So if two people make the same changes, theoretically they will have different commits, I believe. I could be wrong in that, but I believe that the commit IDs here would be different if two different people made the same changes. And there's good reasons for that. What they want to do is fingerprint the who, the when, and the what. Okay? And then your message in your commit is actually the why. Right? The how is like with your fingers. Okay. The how is pretty straightforward with programming. But this is trying to give you all the details you need in order to understand your code. So let me just show you how you could get this. If I did git log, I can see the same kind of things, Mine looks a slightly different than yours, just because of this coloration up here. That's an editor feature of mine that I probably should have disabled. I kind of want this to be as boilerplate vanilla as possible. But my ID here, I think is going to be different. So the last four are BCE4. And if I look at the slides, they're not BCE4. Everybody see that? They're different numbers. So it's a unique ID that I get when I make that commit. And you would get a different one if you made that commit, even if it was the same changes. Okay. And then it tells me who the author is, which is me, and the email address that I've used to sign up for Git, not sign up, that I've configured for Git. All right. So this is the email address that I've set up when I started using Git the first time. And then the time that this message was created and the actual message on the change itself. Okay? So this is sort of like all the details of these changes in my code base. All right.
So the head arrow master notation.
Oh, at the end?
Yeah.
So this is, okay, this is actually why I didn't want to get into it, but what it is that the head, think of the head as sort of like the printer head on your laser printer, and where it's pointing to is where these changes are going to be applied to. And we're going to get into this later, but master is the default place for this. But remember when I said that you can use Git to make experiments, and sometimes those experiments are called branches? You can have a branch with a different name, and I could call that branch experiment, and then head would be pointing at experiment instead of pointing at master.
Okay, cool.
Yeah, without going into like the nitty-gritty details of how everything changes. This is why I actually try to get rid of these kinds of extra information so that there's less confusion that like is hard to, I don't know, carry around in your head when you're trying to think about just the basics of how all this works.
Well, I'm just curious about I missed a spec or something. That's cool.
Yeah, I just wanted to make sure that I answered your question and explained, I'm not trying to hide information out of like malicious thought or something here. It's more of like there's so much stuff to know, and I only want to expose you to so much at a time so that you can just grasp that one thing and then move on to the next thing. Yeah. Okay. Any other questions about that? All right. Cool. Let's check out the next couple of slides really quick. So add versus committing. So why does it have a two-stage commit in Git? That's a good question. The reason is that, I mentioned this before. One is that there are ways that you can add just parts of a file to Git, and that can be useful if you made a lot of changes, and maybe they have different reasons for each one of those changes, and you want to kind of commit in stages. So that's one reason. The other is that sometimes you'll have files in your project, like maybe your project like generates some pictures when you run your code, and you want the source code to be in your repository. But when you run your code and test it, you don't want the pictures to get put into your repository. You don't care about the output. You really just care about the source code that generates the output. And so in that case, you wouldn't add the pictures or the pictures folder. You would just add the source files that you changed that generate those pictures. Okay? Another example is sometimes when you are running applications, you could have a file that logs what the user does. So like visits the about page, visits the index page, visits the company info page. And you don't want those logs to be part of your repository. You only care about the code that generates the logs. So again, this is a cause versus an effect type of distinction. And you, as the programmer, get to decide like what goes in and what stays out of your repository, rather than Git trying to make those decisions for you, because it's not smart enough. It's a really smart piece of programming, but it's not smart enough to understand the intent of your project and know which files are important and which files are not important. That's up to you as a programmer. Yeah, Ron.
Another case, it might be like if you've been coding for an hour or two and you either have to go to a meeting or lunch, you can sort of add what you've done so you have a record of it.
Yep.
But you still have to test the program even
Yeah, sure.
Yeah, that's a good scenario.
Yeah, it's a good point. So it gives you more flexibility.
Yeah.
Gives you more flexibility and more control. Okay, so git add is sort of like, this is a rough draft, and git commit is I'm publishing this.
But if you added and then made changes, you'd have to add again before you commit.
You would. Yep.
Yes.
Yep. And they're going to appear just as though it's, you know, brand new changes to your project. So you git add again. Yep. Okay. Commit hash IDs. I mentioned that these are unique, right? So they're unique both to the change you made and your machine and lots of other things. And this is meaningful, okay? So the idea here is that if you could rewind time and replay the changes you made and running git commit again, you would end up with the same ID. You'd actually end up with the same ID. They're what's called deterministic. They're not random, but they are unique to your user. And that's really important. And what Git also allows you to do when you're referencing these is to not have to type out the whole thing. You can actually only give part of the ID. Typically, it's the last 6 letters, characters, alphanumerics, I think. Yeah, these are only alphanumerics. There's not any kind of like question marks or quotations in here. Pardon me. And that is sort of like a short commit hash. And what it does is it allows you to reference those changes across machines, and because again, most people who are using Git are collaborating. And if you look at this short commit, these ones are the beginning of this long commit, but you could also use the end characters as well. I don't think you can use the middle though. It has to be either the beginning or the end of the commit hash, if I recall. Okay, that's usually how you're going to see these short commits represented. And what this is known as, I don't expect people to like grok all of this, but it's what's known as a cryptographic cryptographic hash, and they use an algorithm called SHA1. So oftentimes that is pronounced SHA-1. So when everybody says SHA, they actually mean the kind of algorithm they're using. It's just like terminology that programmers make up as they talk about these sorts of things. And it assures that no 2 commits will ever have the exact sequence of digits in their IDs. I will say that Git has found that there is a way around that no 2 commits guarantee. So they are moving to a different algorithm, but for like the last 10 years they've used SHA-1, and it served really, really well. The way that they found out that you could actually have 2 commits is there was a team, there are cryptographers, they're experts in this. They use very specialized hardware and very specialized software to try to cause this to happen intentionally in order to prove that there was actually a vulnerability in this. And that forces people to use different algorithms once you've shown that you can, in fact, cause these sorts of problems. But it's called SHA or SHA1. You don't have to worry about really the algorithm too much. Just know like what it does for you. It gives you a unique ID. Connor?
Will shorthand always be 7 digits or 7 characters?
I think it is. Yeah, it's always 6 or 7. Yeah, in this case it's 7.
I have a clarification to that.
Yes.
It's usually 7, but 6 can work if your repository is small. And if it happens that you have 2 commits with the same 7 digits, like that can happen. It's unlikely, but it happens. So then you can use 8.
Okay.
So basically, it finds the first match in the actual history that you have.
Cool.
Yeah. And by the way, Josh, I just checked that the last digit abbreviation, it might have worked at some point, but it
doesn't work anymore.
Yeah. It's
Okay.
just the front.
Just the first 6. Just for 7. Okay.
Yeah. And I think 6 is the minimum. Might be 5 is the minimum to do the abbreviation. It's pretty flexible about that.
So I used a, this is a shorthand that will not work on your machine. This only works on mine. I'll show you what it is in a second. But this is what's called a short log. Okay. You can do something very similar to this by doing git log -- short, I believe. No, is it just short? Nope, hold on. So if I do git log s and I do bitch, it's this git log 1 line abrev commit. So if I do git log 1 line and then -- abrev commit. Do I have one? Where? Oh, it's 1. Thank you. That'll give me this. So these two here can put them all in 1 line. A brev commit means only use the first 7 characters. So if you don't want the full, big, long, you can type all this stuff if you wanted. But git log should work just fine too, by the way. Shouldn't actually be a problem for you. I can show you how you could take this later on. If anybody wants, I can show you how you could take this and turn this into glog s or something like that for your own personal use. It doesn't take very much time to show people how to do that. Okay. So let's do some more shopping. Let's add some stuff to our shopping list. We're going to actually see where Git becomes useful here in just a minute. So far you're like, this is really boring. Why would we use Git if we're just making a silly shopping list? And the point is that we can actually have each one of our changes be tracked, and then we can make some experimental changes later. So let's add some stuff to our shopping list here. Let's add let's add ketchup to our shopping list. So I'm going to come in here, and I'm going to add ketchup in between eggs and Chunky Monkey. So I'm going to say ketchup. Actually, let me replace Chunky Monkey with ketchup, and then take that line out. So say again?
Or Cherry Garcia.
Yeah, I guess I could do Cherry Garcia too, although, that's probably going to taste better than ketchup. I don't know. It depends on how much you like ketchup, really, right? Okay, so I've changed 1 line from Chunky Monkey to ketchup. You'll note that Visual Studio Code is doing a couple things here to help me know what's going on. You see how there's this blue line here? This is just a convention that Visual Studio Code does to tell me that I've changed something. And then the other thing it does is that it puts an M to the right of a file that I've committed and then altered after I've committed it. And that means that this file has been modified. So this has been modified, and this is the line that's been modified. Okay. Now if I go back to what I had before, just a minute ago, and instead I add ketchup here, does everybody see that that color is different? Instead of being blue, it's green. Everybody see that? So Visual Studio Code is telling me I've added a line instead of modifying a line. Okay? So I just want to let you know that there's different colors that are common for different things in Git. Green is common for telling you that you've added something. Red is common for telling you that you've removed something. And sometimes there's a mixture that tells you that there's a modification or this line has been changed, altered in some way. Oh my gosh. Okay. So let me go back to pulling this out and saving this because I do want this to be a modification. I'll come back into here and see what the next steps are. I have to run git status, and after that's done, I can do the next step. So I'll come into my console and run git status after I clear this to make it a little easier to read. And it says that I've modified groceries.txt, but I haven't added it, right? I haven't added these changes back into Git. So now I have to actually add those in. If I do git add with the name of the file, groceries, and I do git status again, I have modified groceries, okay? I have modified groceries. And the next step here is that this has been modified. So it's trying to be helpful. Let's see where we go next. We're going to start modifying some of our contents of our groceries list, and these are the steps we want to do. All right. So we're going to add everything. We're going to run status, and then we're going to commit that our new message is we needed to add ketchup in because we're out of condiments. And then we'll check our status after we're done. So in your editors, go ahead and change your file to add the stuff in, and then let's run these commands and see what happens. So I've added mine already. The last step that I have to do is git commit with a message. If you're on Windows, you have to use double quotes, just a warning, word of warning. And it's, oh no, we are out of condiments.
You also can't use exclamation points.
Exclamation marks are meaningful in Bash. That's why. They're magic inside of Bash, but not inside of DOS. So that's something that doesn't work. You know, every shell, every terminal has its own quirks.
Mm-hmm.
But if you want to use an exclamation mark, you can use single quotes if you're in Bash. Right? So single quotes, inside of single quotes, exclamation mark is not magical.
Yeah, like
Inside
this.
double quotes, exclamation mark is magical.
I thought you just said that we had to use double quotes.
On Windows.
If you're on Windows.
Oh.
So you can't use exclamation points.
And on Windows, you're right. This is welcome to computers. Everything's different for no reason.
Yeah, it took me a while when we were doing this in class to figure out why I wasn't committing. Oh, I have to use double quotes.
So I now have two commits. One that says initial commit, and the other that says, oh no, we're out of condiments. Right? And I was able to get that exclamation point in there by using single quotes. And now if I do git status, I can see that I'm on branch master, nothing to commit, working tree clean. Okay, let's go and do some more fun stuff. Yeah, Ira.
I assume you're going to get to this, but I'm just asking just in case. Commit to where?
Yeah, where is it? You're committing to your local repository. And your local repository is...
Yeah, a different place.
Nope, it's right here. It's in the same folder.
It's in there.
Okay.
It's right here. This is it.
Oh, there's a repository.
Inside the folder. Yep. Which is a confusing point, so I'm glad you brought it up. A Git repository is nothing but a bunch of files. Those files might be in some kind of compressed binary format. They might be inside of a deeply nested directory, but they're still just files. Okay? And so what Git is doing is it takes your changes and adds some files to this repository, and it allows Git to track the status of your changes over time that way. Now, I do not recommend opening this in an editor and going in there. Not because it's scary or there's some kind of like, Necronomicon that will, slowly eat your mind or something. It's that it's easy to accidentally make a mistake and delete a file. And then, in that case, your Git repository might be corrupted and you might lose some of your changes, or you might not be able to do things like commit new stuff. So my recommendation for this is like treat it sort of like the engine room in a building. Like you don't really want to go in there and screw around with stuff, but you should know where it is and you shouldn't be afraid of it. You just shouldn't like go flipping switches. You know what I'm saying? So anyway, that's all the Git is. It's just a bunch of files in the directory of your project that you change.
And it's keeping a copy of each.
It's actually not. It's a little more complicated than that. I think we're going to get into this in another lecture. But it does store the copies. It just doesn't store a full copy of the file every time. It stores some differences in the files. Okay, and it's complicated for performance reasons, but it's very consistent and does its job very well.
So it's kind of a more efficient and like structured way of saying like, okay, instead of groceries 2, because I made some changes, now
Exactly.
I'm groceries 2. Oh, I made some changes, I'll save it as groceries 3. And
Exactly. Yeah, it's like a formally thought out process of saving changes over time by one or more people who are all editing the same code on different computers, possibly at the same time, and are able to keep in sync with each other.
Are they sharing, they're sharing the repository?
Not yet. So right now you've all had your repositories on your local machines, and in the future what you can do with those repositories is send those repositories changes to a place, ironically, a central server of sorts, a GitHub, where people can then get a copy of those changes, make their own changes to those files, and then put their changes back up to that central server. So remember, Git does not need GitHub, but a lot of people use it that way because it's convenient. GitHub is the most convenient way to share changes with files around other collaboration members. Okay? All right. So, yeah, Connor.
I'm just curious if this would be like a realistic use of Git. So like you're working on something, you get it to a point, you upload it or you commit it, and then you work on it a bunch more and say you screw it up or you're like, oh, I don't like what I've done. I want to go back in time and go back to where I had that first commit. Is it, and then so there's a way just to pull down what you'd saved up there?
You don't have to pull down anything. You have it all with you.
You have it with you.
You can go. You can step back in time. Yeah.
And will we go over that?
We will, but not today.
Okay. Cool.
Yeah, you can step back in time, and the future is still there.
Yeah.
So you can go back, make a branch, and the future still exists
Cool.
because you're now like changing the timeline.
Right.
But you are in like a parallel timeline that exists alongside the other one. Yeah, it's pretty cool stuff. I'm not teaching you this tool because it's boring. It's actually really awesome. It's just this part that's boring. Cool. So if I wanted to look at a particular change that I've made, okay, I can actually look at the history, but not actually go back in history. Just look at it, what it was. And so let's actually see some things. So let's say a few days have gone by, you ate all your ice cream, and you know Ben & Jerry's has a bunch of weird names. They're a bunch of groovy guys. And you can't remember if you purchased Chunky Monkey or Jerry Garcia. And so it's an ice cream emergency. Okay, so you need to look back and see what you did in the past. So you could git log to show the full history list, which we're going to do now. Let's do a git log. Git log. This gives us just the logs. You note that it does not show us the changes, just the messages and their IDs. So with that, we can git show a particular ID. So let's actually show our initial ID. So this is our initial commit here at the bottom. We know we only need the first like 6 or 7 characters of it. So if I were to run the command git show with this ID and then run this, oh look, we get more information now when we do a git show. We get to see what's inside of here a little bit. We saw that we added groceries to the Git repository, and I'll explain what all these cryptic characters are in a second. And then we saw that we've added milk and eggs and Chunky Monkey ice cream. Okay, so it actually shows you the changes throughout that particular commit. So what are these minus, 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 and plus, plus, plus? Okay, this is confusing, so let's figure it out. Minus, minus, minus is what was, and plus, plus, plus is what happened after the commit. Okay, so this plus here, these are telling you that you've added these contents to this file groceries.txt. Okay, if groceries.txt had not been empty and instead had files in it, or not files in it, contents in it, text in it, then if you had mutated or modified that text, you would see some different lines here. Let me show you that with the next commit, which is we are out of condiments. So if we grab these and I do, I'll clear this just to show this, git show, and I'll back up to show you both in just a second. So this one is a little different than the last one. Okay, this one is a little different. We notice that up top here, We have the plus milk plus eggs plus chunky monkey. All right, and we have minus 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 dev null. That's a special file that just means nothing. And then plus 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 groceries.txt. So that means we added that file to Git. And then down here we have minus 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 a/groceries.txt. That means version A of this file. And plus 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 b groceries.txt. That means version B. So version A was before the commit and version B was after. And you notice that before the commit, it was chunky monkey ice cream, and after the commit, it was the plus ketchup. So that's what that means, okay? Questions? Concerns? Emily?
What does it mean by dev null? Like for
It's a special place on your computer that represents nothing. So dev null means device nothing. That's what the /dev means. So you can have a bunch of hard disks on your computer, and they would have different device IDs. But there's a special device ID on your computer if you're on a Unix machine or a Linux machine that's called dev null, which means the place where nothing goes and nothing exists. Right? It's like the nothing and the never-ending story. It just, you send things in and they never come out. And so what it does is it represents nothingness to your machine as it's running.
So is that trying to say like it was version nothingness?
It means that it went from nothing to something.
Okay.
Yeah, which is a great question. And I'm sorry I had to go into that kind of detail. Any other questions? Okay, let's see if we can get to pushing before we have to talk about tic-tac-toe. I'd like to see where we can finish this up. So we've shown those. We've shown, let's see, we can, this gives us the full history of the file when we do a git show with an ID. Gives a lot of extra information. This is Chunky Monkey. We should all be able to eat some of that now after going through so much Git. Let's finally talk about diffs really quickly, which is what I just showed you. This is when you run git show, okay, you get this minus 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 plus plus plus. This is showing you the changes in the file. So this was changed, milk was removed, chunky monkey was removed, eggs stayed the same, and ketchup was added in. That's what this is telling you in not so many words in using Git. And you'll get used to reading this kind of output with Git from the command line, and we want you to get used to that. There's a lot of Git clients, meaning like graphical editors that are like fancy and have nice looking elements and stuff. But if you don't understand the underlying parts of like what's really happening, the Git client is just a wrapper around the Git command line client. And if you don't understand what the command line is doing, it's much harder to understand the nice graphical user interface when you get stuck. All right? Right.
What's the blue text there? Above the
It's complicated, but this is actually, means that like, trying to remember. It's a format for a particular kind of tool that is used to tell the changes in the file as it was progressed from one to the other. Alex, JP?
I know this. It's called a patch file.
Yes.
And a diff is also known as a patch. It's a very, very old Unix file format, like from the 1970s.
Yeah.
So that's one reason why it's so hard to read.
Yeah.
Right? So that double at, I don't know what that means. -1, 3 means like from line number -1 to line number 3. That was like the first version, and then the second version only has lines 1 and 2, right? So the first version had 3 lines, and the second version has 2 lines. Again, I don't know why it's -1 and +1 instead of like 1 to 3 and 1 to 2, right? But there's details about that, so that a program called patch can take a file like that and apply it to a file, and poof, out comes the new file.
Yeah. Remember when I said that Git is designed to be used by sending differences over email? This is the kind of differences that they send. So they'll send you an attachment that has a patch file in it, and then you open that attachment using Git, and it applies those changes to Git from your collaborator. And so it's actually a really nice process. Like people who use it really like it, but it takes a little getting used to do that. Okay. All right, cool. So let's see if we can get through this. So one more thing that we need to cover here, we haven't yet, is that we've only been working on our local machines when we made these changes. And Git is a tool for collaboration. That could be a collaboration between yourself in the past and yourself in the present, but more than likely it's a collaboration between yourself and some other human beings. So there are two other commands that Git has which are pretty useful. One of them is push, git push, and the other one is git pull. So as the names imply, git push means sending your files from your machine somewhere, and pull means getting files from somewhere else onto your machine. Okay? These were actually pretty well named. So I think that whoever named these should, feel okay about it. Now, it would be great if there was another command called git sync, but that does not exist. So you have to run both of these commands separately in order to get your changes somewhere and get changes from somewhere else back onto your machine. Okay? So we're going to try to run some of these. GitHub.com is the most common place to do this. There are some others. There's one called Bitbucket that's run by the people who own Jira. They're a company called Atlassian. Bitbucket is also pretty common. There's another one called GitLab, which has become more popular recently. It's like an open source version of GitHub. And there used to be some other ones as well. There was a very famous tragedy that happened with a company called Gitorious, where they were hacked and they lost all of their customer accounts, and essentially their company shut down within 24 hours. And there's some other ones out there that are pretty popular among certain types of groups, but you're mostly going to hear about GitHub, Bitbucket, and GitLab, unless your company has you use theirs for some weird reason. So we're going to do that now. Let's run this lab. So now you're going to need to use GitHub. So if you don't have GitHub open yet, open it in a browser and sign in. Okay. And once you have signed in with GitHub, what you're going to need to do is create a repository in GitHub. And I'll try to show you how to do this if I can. We're going to name that repository shopping. Okay. We do not want to initialize that repository with a README. When it asks us on the following screen after you create the repository, do you want to initialize it with a README? Do not do that. And there's a good reason. Because when you do that without a README, on the following screen, there will be three options. One of those options will be, if you already have code in a repository and you want to push it up to GitHub, follow these instructions. So we're going to follow the instructions that they have set up for us. And then we're going to find and copy the Git URL from the newly created repository that we did. And we're going to follow the rest of the instructions, which include adding that repository as what's known as a remote repository for Git. And at that point, you'll be able to go back to your original terminal and you'll be able to paste something like this: git remote add origin git URL, git push origin master. But the first thing you need to do is follow these instructions from top to bottom. And in particular, follow these instructions if you already have a repo already. All right, these need to be followed. If you follow it, it's just 2 lines where you're going to add the remote repository and push to it. You'll have the code that you've written for your grocery list up on GitHub, and then somebody else, like the person sitting next to you, would be able to get those changes onto their machine without you having to hand them a USB disk, USB drive, or a CD disk or something like that. You can just send your changes back and forth through GitHub, and it's very convenient. All right, so start doing this now if you haven't started already. All right, and we'll go from here.
Is that my username?
At which stage?
After I typed in git remote add origin and then git push.
Yeah, so that it's asking you for your GitHub username. This is probably an SSH key.
I can help her.
Yeah. Okay. Cool.
Yep.
Great.
Is it gonna be well? Like, is it gonna be
Let me just see the details. So yeah, so this happens when